Today we will look into calling Rust from C++ and specifically in a JUCE plugin. So how to automate the Rust build in the background, that you just build your JUCE plugin like always. In the background you will have the Rust code that is getting built and integrated as a static library into your plugin. So you don't have to care about a lot and you can write way safer DSP code in the end. Yeah, here I just have a very basic gain plugin. Let's just listen to it. Yeah, the gain works perfectly fine. And let's have a look which code we actually call. This is this Rust code. So as always, I have a repository for this here, Rust CPP, and then go to the branch JUCE integration. And here you will see in the migrate folder, you will see this lib.rs file. And here is this process channel gain function. And this just takes a mutable slice to F32 values. So it's a pointer and a length basically. And then the gain value we want to set. Here we can use the nice Rust iterators. Just call iter_mute.forEach and then multiply each sample with our gain value. So very basic function. But the cool thing is, with this little tool called CXX, we can publish our Rust functions, Rust structures, even some more complex types to C++ and get a safe wrapper. And everything is built automatically. So we can directly call this function here from C++, which is pretty cool. So you have to build this module. We usually call it FFI. Give it this macro CXX bridge, so the code can be generated. We can namespace it, and then you can call this extern Rust. And here you just publish the function headers again, which you want to make accessible from C++. You can also use that here with extern C++ to call C++ functions. So if you want to get some state or whatever from C++, so that works kind of nice. Let's have a look in CXX. Sorry for the bright screen, they don't have a dark mode. CXX.rs is a framework, is this framework to generate those bindings to the hidden C ABI. And here you also have some examples for CMake integrations, so that CMake stays your main build system, what is common if you build your JUCE plugin, right? And you just call those Rust functions. And here you see which types are supported. So the built-in bindings, for example, string will generate the Rust string type in C++. So you can set it and you have all those functionalities on this type just to make it a bit safer. Also, this nster is supported. Here are the slices. Those are the ones we use. So we can call our functions with a safe slice because the slice can be generated out of a pointer and the count. Yeah? So kind of simple and pretty cool. So also vector here supported and so on. Yeah, even the box here. Box is this heap allocated thing. So pretty nice little framework here. And we start with a JUCE plugin. Yeah. I usually start to build JUCE plugins with CMake. We don't want to go too deep into it, but I just start with this example. So this is the usual JUCE framework. Examples, CMake, and here's this example audio plugin. So we start with the CMake lists file. That's just this basic plugin. Let's go to our new project that is empty. New file, CMake lists. Here. So everything that is doing is calling a new CMake project, then adding this JUCE API to add an audio plugin where you can set all your settings. Here you add your sources, your source files for the plugin. There are some compile definitions for JUCE specific stuff, and here you link libraries, and this is the place where we later also link our Rust library. So yeah, this is the file. There's some stuff I'm adding just to make it nicer to use. Oh, there's actually an update for that. Let's do that. Nice. What I usually do, let's go here. Here's the full example, is the export compile commands. This is just necessary so we can use the LSP here inside of Z or in VS Code, yeah, or in other IDEs. Yeah, that's not necessary if you use VS Code, Visual Studio or Xcode, I think, but for a lot of IDEs this is necessary. If you want to use ClangD, for example, then let's check what else I've done. I just made here this CMake CXX standard, so not absolutely necessary to call here. I think JUCE anyways does this in a way. And now the only thing is we need to find JUCE as a package. We need to install it. Yeah, it's not yet. This CMake file doesn't install the JUCE library or add it as a dependency. So either you have it already on the system and you can add it here. You can add it as a subdirectory, like the whole JUCE repo. What I like to do is just using fetch content. It takes a little while. It's a bit longer, but it's very simple to use then. Yeah, so, you can just fire and forget and call the script from any computer. I like that. 807, what is actually the current version? This is JUCE. Let's check what is the current version. There's 808 already. Let's use the newest version, why not? Yeah, and this just gets it from the Git repository. Here's the version, and this just helps for very long and big repositories to make a shallow copy that it's not cloning everything from the history, and we see some progress. So this is just recommended for very big repos like JUCE. All right, yeah, this does nothing than just downloading the Git repository and adding it as a subdirectory, basically, and building it. Yeah, it's not that much that is happening here. Anything else to do in the CMake file? I don't know. Let's go through my example here. No, that looks fine. And then we have to add our plugin editor stuff. Yeah, we just added from here. So plugin processor. Let's copy this. Plugin processor.h, then the CPP, duplicate. Did I write this correct? Yeah. So this didn't work. GitHub sometimes doesn't copy the stuff here, right? All right, that's the CPP file. Then we need the plugin editor.h, plugin editor.cpp. No. Let's copy those two files. Please copy it. Yeah, that's the editor. Oh, but I did it in the wrong file. This is the editor.h. Let's go to CPP. All right, so our chores here, just copy this default plugin. And now we can already try if this stuff here builds. Yeah. What you can do is just calling, now we have to learn CMake again. We're not in Rust land. So I usually just do CMake -b build. I don't remember if how JUCE is built in release mode. I mean, it doesn't matter now. Yeah, but you also have to call this CMake build type release. Now it is downloading JUCE. This will take a while. Yeah. It clones the GitHub repository here and so on. So yeah, this always takes a little while. Let's see if everything works in the end. And here in dependencies, you see now here's the JUCE source. Yeah. So everything will be cloned here into this if you want to look into the files. Yeah, now we see here are all the JUCE examples. So we actually could have called this first and then just copied the source code here. A bit easier than copying everything here by hand. But let's wait. Yeah, you obviously have to make sure that you installed all the JUCE dependencies like WebKit2, GTK+. I think if you're on Linux, yeah, this should be in extras, no, in docs, and Linux dependencies. Yeah, here are all the dependencies. And for Fedora, I just put this into Claude or any other LLM and let me transform this into DNF. Yeah. Let's see. Okay, this worked. And then we have to call the second command. Yeah, I also wrote this down here. CMake build -- build. Yeah, that is our build folder. And -j is again just to use all the cores on our CPU at the same time. So that looks good. It does something. Yeah. Now my computer is roaring a bit. It's interesting. I'm not used to that anymore. Like those NIH plugins we built before, they build a little bit faster, in my opinion. But let's see. Oh, it's actually not that long here. All right. What do we have to do next when the plugin was building? Let's just hope it works. We have to generate our Rust crate, yeah? Or maybe let's directly look into this example. Sorry for getting bright again. Next time I warn you before. Here is the CMake tutorial, and there are some examples. I actually just go with the first one. I didn't use link time optimization for my case now, but yeah, this is just a little example that someone did. And here we can see what is actually necessary. We have to create a normal Rust program, and the Rust program contains a CMake file that does not much more than setting the cargo command, so cargo build release. Yeah, it checks here if we build CMake for debug mode or for release mode. So then we just set the normal cargo build command or the cargo build release command. And I think here, add custom command, actually this command is called, let's see, where is it? Cargo command. I don't know where it's called right now. Ah, here. So here we call the cargo command. So you can just add custom commands to CMake that it should call, and it's as easy as this. Yeah. Yeah, the library gets added, so it's not a lot of stuff actually you have to do. Target link some libraries, also this Rust lib. And is there anything else? Yeah, we need the build.rs file. This just tells CXX to build this bridge, yeah, this bridge that we had here. In this example, it's a bit more complex, but in our example, there was just this one function. And something else, we have to obviously add CXX as a dependency and also CXX build as a build dependency. And yeah, the main thing actually, we have to set the library type to be a static lib, so it builds a C-compatible .a library in the end that is integrated into our JUCE plugin. And in the main CMake file, I think this is only for LTO. We don't need this right now. Yeah, we just include the directory with the Rust library, and then here link the actual Rust library. So that's really all you have to do. Maybe, I don't know if we should write all of this now here. Let's see, the plugin did build. That's fine. That's nice. Let's see if our LSP here works now. Yes. So now, yeah, just because we set CMake export compile commands, we can use just Z. Yeah, Z by default has ClangD integrated. I think it's ClangD. So we can just load C++ project and have all the highlighting and yeah, LSP stuff. So here you see when we type JUCE, yeah, we see all the different JUCE functions here. Very nice, very easy. Okay, then let's add our Rust repository, our Rust library. Let's just say here cargo add lib, and we call it, yeah, here we can call it Rust part, like in the example. I think there's something like that it doesn't use Git, because by default it will use Git, but we don't care right now. Sorry, that's cargo new. And then here we have the Rust part. Yeah. We can remove the Git repository of this because we don't need it. cd Rust part, remove -rf.git, and also the .git ignore. Okay, that's nicer. So we don't have a Git repository here inside. Here's our lib.rs file, and let's have a look. So cargo.toml, we need to add cxx as a dependency. Let's say cargo add cxx. And then also cargo add build cxx build. I think it's called like this. Let's see. Yeah, that worked. Yeah, so now we have the dependency and the build dependency. And the other thing we had to do is setting here the crate type to a static library. Now I usually like to do this at the top. So we built this .a in the end, this .a file, or how is it called on Windows? .lib maybe. Okay, something else to do. We have to add the build.rs file. If you haven't seen the build.rs before, build.rs is just a Rust file that gets called before or during the compilation, so before our actual code gets compiled. Here we can generate new code, do whatever we want, so it's like the CMake script for Rust, basically. But in Rust, it's cool that we don't have to learn another language like in C++. We can still use Rust to build the compile time stuff. The build script is very easy. We just say it should build our bridge, cxx build, and rerun the script if our lib.rs is changing. And in our lib.rs now we can just add the Rust stuff here. We just copy this now. So this is our actual cxx bridge here, like we said before. And we can also call this Rust part. Doesn't matter how we call this, so everything's called the same. And this is our function we want to call. Yeah, this can get very complex. I think here you have a better example of what you can do. You can have share types. You can have full structures that are public with all the members that are public to C++. So that's pretty cool. But that's all we need to do here. And the rest is now ugly CMake stuff. Let's add a CMake list.text to the Rust part. And we basically just have to copy this here. Yeah. Let's copy this example. We have to check that the paths are all okay. So this command is right. This is just for cross-compilation, so we can set another target. We don't need this right now, so we could just make it easy and remove this for now. The LTO we also don't need for now. This needs to be the right name, librustpart.a. For us, that's okay, because we are on Linux, we built a .a file, and also it adds lib before. So if our executable here is called rustpart, then this will be called librustpart.a. So that's fine. And here is the rustpart.cpp file. This will be generated by cxx. So it will have the same name. That's fine. And here we add the library with the right name. So if you change this name, you have to see that all those names here are according to your crate name. Yes, we just ensure this. But this is all fine because we took the same name, and I think that's it. Then we go to our JUCE plugin again. And let's see what we have here. This is all already done. The enable LTO stuff, we don't need that. We really just have to add include directories. Let's see where we do this. I have no idea where's a good position for that. Maybe just do it here. Include directories Rust part, that's fine. And then add subdirectory and add executable. We don't need this because we already have this JUCE add plugin which adds this executable and so on. And we need to link the library Rust part. And here we can do this inside of here in the private section. Yeah, this is then our Rust library. So that's all we need to do. Let's double check if I've done something wrong in this CMake file. Here I just made it a little bit smarter with setting a Rust crate name that we can use, so we don't have to change always all those CMake files. And yeah, I think here I do the same. Here's the Rust crate name then, yeah, doing the Rust library. Did we do something else? Here include directories include. I think that's not even there. I don't know if we have to add this. Let's see. Let's add it for now. And maybe that's it. I hope so. Let's try to build it. Or I have to stop removing this. CMake. Where was our CMake command here? I don't know if we forgot something. Let's just try it out. Okay, yeah, that didn't change. But then our actual CMake build command should now build our Rust project. Oh, I'm sure we forgot something. That looks actually quite good. What I don't like is all this crazy stuff here. So I would prefer to remove the verbose here. I don't want to see this actually right now. It's just annoying. But it's looking good, yeah. If we scroll up again, you see it was compiling CXX, it was linking C++, it compiled all the Rust crates. Yeah, pretty cool. So let's try, if this is done, let's try to access our actual Rust function here, yeah. Let's go into our process function, plugin processor.cpp, and then here you have all the functions. The process block is the right place to do it. Here's our audio channel data. Let's just now access it like this to see if it actually worked. Rust part it's called, right? I think we have to include rustpart.h. There it is. Yay, the file is found. That's very nice. And check if CMake would always be this easy, right? I trained this before, so don't worry if you have some problems. CMake can be pretty tough sometimes, but I hope you can follow along. So let's check this, Rust part. And here we have our function, process channel gain. Yeah, and now you see it wants a Rust slice. So this is a newly created C++ type, just to interfere with our Rust code, and it wants this gain. Yeah? And the Rust slice, we can actually create it just inside of here or here, auto channel data, or we are in, this is already called channel data here. Let's just call it slice equals, now it's Rust slice float, and I think this is the right one, and then we want to put in our channel data. This is the pointer. Yeah, this should actually accept a pointer and a length, and the length is not the number of input channels, but I think buffer dot get num samples. So that's the number of frames actually in our buffer. Yeah, here this as well. Let's see why this doesn't want to work. We are not in our for loop. That makes sense. So we remove this ignore unused because we use it now. And then, yes, now it works. See, we have our Rust slice. So it takes the channel data float pointer now. And here it's just complaining, ClangD is complaining that we do an implicit conversion from int to size t. Yeah, we can use this static cast size t. Actually, yeah, there are so many ways to do this in C++. I learned once that this is the right way. Let's hope that's still valid. And tell me if there is a better way or if you should use the size t kind of differently. but I think that's the way I always did it in C++. And then we call our process channel gain function in Rust. That is, let me check, slice, and then our gain. And our gain could be 0.5 or something now, yeah, just to test it if it actually gets quieter if we use the plugin. And I think that's it. Your job is done. In this, very simple case, we don't need a struct or something here, but you can do all of this, Like I said, now we can go crazy and build complete structs that are known to C++ that we can store. Everything will be generated for us. And you saw we really had to do nothing but work with the CXX bridge here, and all the stuff gets automatically generated. Maybe let's have a look into this. Here's the Rust part. So we see in build Rust part, we have this rustpart.cpp file and .h, and here all the crazy types are defined that we need for this interface. And also rustpart.cpp, here's the slice and so on defined. So there's all this interface stuff automatically generated for us. I mean, what else can we do? We can try to build it. Now we see linking CXX static library. No, it's fine, I think. Sometimes I think with this approach right now, when you do changes here, it actually doesn't get fully rebuilt. Then you can try to delete the build folder. And I actually couldn't find out what is the problem. I don't know why CMake doesn't rebuild my Rust part then, because actually it has this command and the build.rs file should check when. I'm not sure. Try it out. Maybe you find a solution, let me know how this gets updated automatically. But we already had this in the first build. I think that's why everything is here. It's built. Cool. And I think if you want to make your life a little bit simpler, you can even use, sorry, I'm scrolling around too much. You can use copy plugin after build. You can just add this to true. And then if we do that, I think this is audio plugin example, I mean, let's hope we don't crash everything here now. But let's build this again, and then our plugin should be automatically copied after the build. Sometimes I'm not sure with C++ if I have to call configure again or not. I don't know. This is all stuff we don't have to care in Rust anymore, right? We just have cargo build, and there's no configure or build or this weird -d CMake build type equals release. Who came up with that? We have to build and release so often. Whatever. And here we see it worked. Installing plugin example VST3 into our .vst3 folder. So that's fine. It should be here now. So if we remove this, the slider should be gone, because I was building the slider here in the GitHub repository here. If you want to check out how I did this, check this. Here's the slider, gain slider. And I think here I just connected, if we go to the processor, I just connected the gain parameter here with the actual parameter value. Let's have a look. Delete the plugin, reload it. Okay. That worked. We have our plugin now. It's just saying hello world, because this is what we copied here. This is our plugin editor. It's not just saying hello world. And now, if we are lucky, we hear a difference of volume, because we set the gain to 0.5. Yay! So the Rust code is getting called and is changing the level of our audio file. That's super nice. I think that's it for today. I hope you were interested and you like this format where I actually code the stuff live. Yeah, I'm not sure. Before I was just showing the code, but I think maybe you can learn a little bit more if I just code it. I'm not sure. Yeah, it also takes a bit longer. So please give me feedback, and I'm happy if you, comment, subscribe, whatever. It's really nice to get your messages below the videos. And yeah, if you have ideas, what you want to learn, what we can go through. But I think actually here this is super interesting because a lot of you might not be ready to switch to Rust completely for plugins because this NIH plugin framework isn't that far. There are no audio units and so on. But this is a nice way how you can use very nice, safe DSP in Rust inside of your JUCE plugin. So yeah, bye-bye. Have a great time. See you soon.